Good morning, children. As already we have studied about light, reflection, and refraction. I told you in the same way with sources of energy. So if you go with BBT here, so the figures and everything, so you will understand more clearly, so that you can understand more clearly, and it will be very effective for you also. So go through this also. So here the same chapter, light, reflection, refraction, already explained you there. Now we are going with this one. So I told you what is light is also. Light is a form of energy. First thing is, what is light? Light is a form of energy which helps us to see the objects. So we can see the objects through light. And second thing, when light falls on the object, it reflects the light, and when the light reflected, light reaches our eyes, then we see the objects. For example, I told you, if you want to see the object, it is dark, so if you want to see the object, what you will do, you will take the battery and you will focus the battery on the object which you want to see. You will not focus the battery to your eyes. Why you have to focus the battery to the object, not to your eyes? Because eyes are seeing, no? You can focus to the eyes, but no, that we are object in there to the object. Why? Because this reflection is there. When the object reflects the light, is reflected in your eyes, then only you can see the objects. The common phenomena of light is the formation of shadows. I told you already in the class form. Because when light is there, shadow is there. Without light, there is no shadow also. Formation of images by mirrors and lenses, bending of light by a medium, twinkling of stars, formation of rainbows and everything. It is formed by rays. You can see the examples here. Formation of light is given there. See, that's why I told you. This is the battery. If you want to see the object, you will not put the battery to your eyes, but you will put the battery to the object. So when you put the battery to the object reflects to your eyes, then only you can see this object very clearly, or else it is impossible to see. Same thing with that also. Here the traveling of light is given, and in the picture, so equal angles of reflection, angle of incidence, angle of reflection. This is called angle of incidence. Incidence means where the light is falling. After falling, the light reflects back. It is called reflection. On this we have some laws also that we will study. And in this picture you can see there. Here you can see this is the original pencil, or which is the original rod, whatever it is. But if you see in this way, it is little bit bended here. The original position is this, but we will see in this form. Why it is like that? Means it is because of process called refraction, not reflection. That is process called refraction, but here it is reflection. It is reflection here, there it is refraction there. Same thing, formation of rainbows here. When the light passes through the small droplets of water, the rainbow is formed, and you have the prism there. There is reflection of light. So you can see the VIBGR, formation of VIBGR here. When the white ray passes through the prism, it gives 7 colors, what we call it as VIBGR, the white of the prism there. Okay. Next we will see very important one, very sub concept. I told you we have laws of reflection of light and laws of reflection of light. I told you this is very important. What is first law? The first law says the angle of incidence is equal to the angle of reflection. So what I told, the angle of incidence means where the light is falling. This angle, when you draw a straight line here, the angle of incidence, this angle will be always equal to the angle of reflection. This is the first law. So this is a very important one. You may get the question, state the laws of reflection of light. So first law is the angle of incidence, where the light falls, and where it reflects will be always equal. The angle of incidence is equals to angle of reflection. And second law is the incident ray, the reflected ray, and the normal to the mirror at the point of incidence all lie in the same plane. Means if you take a glass which is of in a square shape, and if you pass the air into the glass, what happens here is the incident ray, the first ray, and the normal line, which you draw a straight line, and the angle of reflected ray, they all lie in the same plane only. Same plane in the sense it may be mirror, whatever it is. They will be always in the same plane only. Means the incident ray, the refracted ray, and the normal, they all three lie in the same plane. These are the two laws of reflection of light. This you should understand. Okay. Here we have spherical mirrors here. Spherical mirror is a curved mirror which is a part of hollow sphere. Spherical mirrors are of two types. There are concave mirror and convex mirror. This I told you already. Two types of mirrors we have. One is concave and one is convex. What is concave? I told you. Take a spoon. Okay. You have spoon in your home, no? So while eating, what you will do? The blood space ಒಳಗಿರುತ್ತೆ, ಒಳಗಿಂದ ಏನಿರುತ್ತಲ್ಲ ಅದು ನೀವು ಕಾನ್ಕೇವ್ ಅಂತ ಅನ್ಕೊಳ್ರಿ. ಮ್ಯಾಗಿಂದ ಏನು ಬರುತ್ತಲ್ಲ ಅದು ಯು ಕಾಲ್ ಇಟ್ ಎಸ್ ಕಾನ್ವೆಕ್ಸ್. ಸೊ ಇನ್ಸೈಡ್ ದ ಸ್ಪೂನ್ ಈಸ್ ಕಾನ್ಕೇವ್, outside the spoon means the bottom of the spoon is convex. So concave and convex. Spherical mirror whose reflecting surface is curved inwards. Curved means in spoon alli curved hengirutte, it will be inwards in the curve. What is convex? The outer side of the spoon. The spoon, the outer side ಏನಿರುತ್ತಲ್ಲ ಅದು ಹೆಂಗಿರುತ್ತೆ, ಬ್ರಡ್ಜ್ಡ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾನ್ವೆಕ್ಸ್. ಆ್ಯಂಡ್ ಇನ್ಸೈಡ್ ದ ಸ್ಪೂನ್ ಏನಿರುತ್ತಲ್ಲ ಕೇವ್ ಅಂತಿರುತ್ತೆ. ಒಂದು ಲೆಕ್ಕ ಇಟ್ಕೊಳ್ರಿ, ಕೇವ್ ಅಂದರೆ ಏನು? ಜನರಲ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಗೋ ಫಾರ್ ಇಂಗ್ಲೀಷ್, cave means, see, so I told you concave. Cave, we have the word there, CONCAVE. If you can't remember what is concave, then remember the word cave here. Cave ಅಂದರೆ ಕನ್ನಡದಲ್ಲಿ ನಾವು ಏನು ಹೇಳ್ತೀವಿ, ಗುಹೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಗುಹೆ ಯಾವಾಗಲೂ ಒಳಗಡೆ ಇರುತ್ತೆ, ಹೊರಗಡೆ ಅಂತ ಇರಲ್ಲ. ಗುಹೆಯಲ್ಲಿರುತ್ತೆ. ಗುಹೆ ಒಳಗೆ ಹೋಗ್ಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಒಳಗೆ ಹೋಗಬೇಕು. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ಸೈಡ್. So it will be inside, it will be birds. Then only we call it concave. Okay, convex means the outside of the spoon. If you take the spoon, it will be the outside of the spoon. So I told you always, concave means which will be inside. Cave means inside, it will be there. So we'll go inside, no? Then it is inside. So convex means if it is inside, the remaining is outside only. The remaining part of the outside is called convex part. So one is concave, another one is convex. These are the two types of mirrors you have, concave mirror as well as convex mirrors. Okay children, we'll go to the next part. Okay, we have the definitions of the things here. If you want, you can copy it. It is already sent in the study material also. Already I explained you also. So what do you mean by center of curvature? What do you mean by radius of curvature? Pole, principal axis, principal focus, focal length. One thing you remember, if you know only these terms, then only you can draw the ray diagram. If you don't know these terms, then it is impossible to draw the ray diagram. At least you will get one question on ray diagram. Draw the ray diagram of concave mirror or convex mirror, or concave lens or convex lens. It will be of 2 to 3 marks you will be getting there. So by heart these definitions. If you want by heart, at least try to remember what you mean by center of curvature. In the center of, already I explained you the figure on the board also in the that class, our class. So in this here, just you go through it. What do you mean by center of curvature, radius of curvature, pole, principal axis, principal focus, and focal length. Okay. So that's what I told you. Here is on X, C, F, P, Y, but he has not mentioned where they are. I told you already. C is called center of curvature. So you will be have center of curvature here. CP is radius of curvature. From here to here it will be center radius of curvature. Pole of XY he has given. From this pole to this pole he has not mentioned there. And we have principal focus, the straight line which is passing to the center of the mirror or lens. And we have focal length, the point where all the rays are meeting at one point, whether it is a lens, sphere, whatever it is called focal length of the lens. Okay children, reflection by spherical mirrors, this is not for you, just you will learn in the higher classes, that we'll see afterwards. What is there in your textbook, that will be explained here. Image formed by concave mirror, this is there for you. So how the images are formed by concave mirror? One thing remember, when the question is asked how the images are formed by concave mirror, when the object is at infinity, the image is formed at the focus. It is highly dimensioned, real and inverted. Highly dimensioned means the main thing is where you cannot see it properly, but it will be real. Real means the object will be real, and it will be not straight, but it will be inverted when the object is at infinity. So you may get the question, what is the object, what is the position of the object when it is at infinity? So your answer should be, it will be highly dimensioned, real and inverted. Okay. When the object is beyond C, so this is also not there for you, just for your information. When the object is beyond C, you know what is C. That's why I told you C directly is mentioning beyond C. But if you don't know what is the meaning of C, center of curvature it is. The image formed is between C and F. Its dimension real and inverted. Everything is given in your textbook in the form of a table. Just if you go through the table, it is enough, because in one table he has given everything here. Clearly he has given there. That's what I explained in the last class. So you go through it, it will be very easy for you. Okay, instead of going one by one, if you see the subject, if you see the table, so one table, in first table he has given when it is in the focal length. In the second point he has given where we have first one, that is concave. Here you have the picture of position of the object here, position of the image, size of the image and nature of the image. He has given at infinity, at the focus F, highly dimensioned, point sized and real and inverted. If it is beyond C, then it is between F and C, dimensioned, real and inverted. And if it is at C exactly, so the position of the image will be at C, very important one. When it is at C, the position of the image is exactly at C, and size of the image is same size and real and inverted. And here between C and F he has given beyond C, enlarged, real and inverted. And at F it is given at infinity, highly enlarged, real and inverted. And between P and F it is behind the mirror, it is enlarged, virtual and erect. This is about the point 1 here, concave. So go through this. I told you already, you give more importance to this point when it is at C and between C and F. Then we'll go for the second one, that is convex. Let us see how the formation of images will be there in convex mirror. Children, the tables which we are showing is in your textbook also, so you can refer to your textbook if you get the doubt also. So whatever you are doing, so all these tables are in the textbook. So this table is in your textbook in page number 88. If you want, you can refer there also. So it is convex, it is not concave. So he has given position of the object, position of the image, relative size of the image and nature of the image he has given there. So at infinity same, at focus f2. F2 is nothing but, I told you, focal length of 2, because we have taken two lenses here. Two lenses in the sense, if you take one, it will be like this. So here we are taking like this 2 here. So it is one part of the lens and this is another part of the lens. So you are having two lenses here. So this side if you go 1, this side if you go on 2 focal lengths will be there. The reason why it at focus f2 he has taken there. And highly dimensioned, point sized, real and inverted. And beyond to f1, between f1 and 2f2, dimension, real and inverted. At 2f1 same size, real and inverted. And it given at focus f1 at infinity. This is important one, you note down this one. At focus f1 it is infinity. Infinitely large or highly enlarged, real and inverted. This is important. Infinitely large or highly enlarged. Infinitely large means we cannot imagine also. Highly enlarged means it will be very big. Okay, that is there. Generally this we will see in cinema theaters. Generally, you know, the difference between the lens and the object and the screen now what we used to have there. Everything will be on this basis only. That's why we will get infinitely large or highly large figure there when we compare with the projector as well as on the screen there. This is very important one. And between focus f1 and optical center O, on the same side of the lens as the object, it is enlarged, it is virtual and error. Okay, this is of convex, and you will see I told you give importance to these tables, which is also from the textbook. I told you from page number 88, so you can go there and you can have the same table in your textbook also. Okay, we will move further. Okay, children, next we will have uses of spherical mirrors. So first one is concave mirrors. So where we will use concave mirror generally. So why we are studying all these things? So the main reason why we are studying means because their uses are very, very useful to us. So when you are placing the object in between the lens and the object, how it is formed and how the size of the object is there, everything you will study now. For example, concave mirror. What are the uses of concave mirror? He has given there. Concave mirror are used in torches. You can see the torch here. Searchlights. same thing, and headlights of vehicles to get parallel beam of light. Parallel beam of light in the sense, if this is concave, the lights will be always parallel. If the light is parallel, they will be strong and they will be bright also. That is the reason why they are used in torch or magnifying many big light systems or in vehicles also, headlights also. So that the light will be very sharp and it will be of very great focal length. So the light will be, more illumination will be there in this part. They are used as shaving mirrors to see larger image of the face. So in shaving mirrors also means, if you have been to salon, there you can see the difference between you and the shape of your face in the mirror there. If you observe carefully there, to see larger images. Here larger images in the sense, I gave the example of cinema theater there. So the focal length will be different for each and every mirror. So if you want to buy the mirrors, we cannot buy the common mirrors for everything. So there will be difference between different mirrors for different according to their uses. So according to their uses only they will go with the focal length and everything else. Or else if don't, all mirrors will not work as usual or what we are thinking. So different functions of mirrors will have different uses there. So we will use in different parts there. So they are used by dentists to see larger images of the teeth. Same thing. If you go for a dentist, if you have a tooth pain, a teeth pain, so you there, if you want to see the dentist, you will put one small thing inside your mouth there. See, you can see this figure here. So what happens here is, the doctor can see the larger image of your teeth there, so you can see clearly what is happened in your teeth. That's why it is used in here also. And large concave mirror are used to concentrate sunlight to produce heat in solar furnaces. Generally solar furnaces will not have here. Concentrate sunlight to produce heat in solar furnaces means all the sunlights will fall on. Here we have this figure, we can see here, object you can see here. All the lights will fall on here. This will be pointed at one point which will be very strong. It will be very strong and it will be very dangerous also. The temperature will be very more here. These are the uses of some uses, not all the uses. He has given some uses of where we use the concave mirrors. Okay, let us see. Now we studied about concave mirror. Now it is convex mirror. Okay. Now let us see what is different between concave mirror and convex mirror. Convex mirrors are used as rear view mirrors in vehicles. Convex mirrors give erect dimension images of objects. They also have a wider field of view than plane mirrors. Means what? See, when you see the objects here in vehicles, they give erect. Erect means what? Deadly opposite. They will not be same. For example, you might have seen the ambulance there. If you see the ambulance, they will write the ambulance, the name of the ambulance there, totally in a reverse way. Why? Because when you are sitting in the vehicle, if you see in the vehicle also, the reverse way, when you see in the mirror, it will be seen as read as ambulance only. That's why they will write in the opposite way for the ambulance, especially because the driver should understand what is the seriousness, which vehicle is coming behind him, so that he can leave space for that ambulance. That is the reason why they will write the ambulance not in a proper way, and from right to left, and they will go from left to right there. That is the uses of here in vehicles. It may be two-wheelers or four-wheelers, whatever it is. It is rear view images. Wider field of viewer than plane mirrors. Wider field means here, it can be abroad. For example, if you see the plane mirror, if you see the mirror which is in your home, you can see only that part that we are seeing. But if you see in the convex mirror, it will not only be this part. See, you can see here, the convex mirror is here. You can see up to here also what is there. This cannot be seen in plane mirrors. Plane mirrors will be restricted there. So, but you can see up to there what is there and what is moving on there. That is the reason why they are used here in convex mirrors. Refraction of light. So we studied about reflection of light. Now it is refraction of light. I told you what do you mean by refraction of light in the morning also. When the light moves from one medium to another medium, there will be a slight deflection in the second medium. Means ಯಾವುದಾದರೂ ಒಂದು ಲೈಟ್ ಒಂದು ಮೀಡಿಯಮಿಂದ ಗಾಳಿಯಿಂದ ಹಿಡಿದು ನೀರಿನಲ್ಲಿ ಹೋದಾಗ ಅಥವಾ ಗಾಳಿಯಿಂದ ಹಿಡಿದು ಗ್ಲಾಸ್ನಲ್ಲಿ ಹೋದಾಗ ಒಂದು ಮೀಡಿಯಮಿಂದ ಇನ್ನೊಂದು ಮೀಡಿಯಮ್ ಪಾಸ್ ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸೆಕೆಂಡ್ ಮೀಡಿಯಮ್ ಏನಿರುತ್ತೆ, ಸೆಕೆಂಡ್ ಮೀಡಿಯಮ್ ವಾಟರ್ ಇರಲಿ, ಗ್ಲಾಸ್ ಇರಲಿ, ಏನಾಗುತ್ತೆ ಅದರಲ್ಲಿ ಲೈಟ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಸ್ವಲ್ಪ ಡಿಫ್ಲೆಕ್ಷನ್ ಇರುತ್ತೆ. ದಟ್ ಡಿಫ್ಲೆಕ್ಷನ್ ವಿಲ್ ಬಿ ದೇರ್. That deflection is there. That process of deflection is called refraction of light. Sorry. When light travels obliquely from one transparent medium into another, it gets bent. Bent means bend agodu. Generally we use the word there. This bending of light is called refraction of light. When it enters from one medium to another medium, then only. The where it bends, it not bends in the first medium, it bends in the second medium. Bends towards the normal. When light travels from a rarer medium to a denser medium, it bends towards the normal. When the light travels from a denser medium to a rarer medium, it bends away from the normal. This is very important. What he is telling is rarer medium to denser medium. Rarer to denser. You know what is density? This I think you studied in 9th standard, but I don't think if you remember. What is density? Density equals to mass by volume. I used to ask one question. If I take 100 kg log and the 100 kg ಕಟ್ಟಿಗೆ ತೊಗೊಂಡು ಕಟ್ಟಿಗೆ ಅಂತಂದರೆ ಯಾವುದೋ ಒಂದು ತಗೊಂಡು ಲಾಗ್ ತೊಗೊಂಡು ದಪ್ಪಂದು ಮರದ ಯಾವ್ದು ಕೊಂಬು ತೊಗೊಂಡ್ರೆ ಆ್ಯಂಡ್ 1 ಗ್ರಾಮ್ ಅಥವಾ 10 ಗ್ರಾಮದು ಒಂದು ಕಲ್ಲು ತೊಗೊಂಡ್ರೆ ಎರಡು ನೀರಿನಲ್ಲಿ ಹಾಕಿದ್ರೆ ಇಫ್ ಯು ಪುಟ್ ಬೋತ್ ಇನ್ ವಾಟರ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್? The stone which is a small one of 10 grams or 20 grams, it sinks into the water. Where is the log of 200 kgs, 100 kgs, it won't sink in the water, but it starts floating on water. See, just of 10 grams or 20 grams of stone is sinking in water, but whereas log of 100 kgs and 200 kgs is floating on water. Why it is happening? I explained in detail also in the class also. So it depends upon the density, what we call denser. Denser means generally here lower density, higher density, or higher density, lower density. When you compare water and glass, water has the higher density, glass has the lower density. If it is the condition, so when light travels from lower density to higher density, then it bends towards the normal. Bends towards the normal means it comes towards the normal. When it travels from denser to rarer, then it bends away from the normal, means it moves away from the normal. That is the reason why you see when you put your finger inside the water glass, you can see the bird's finger ದಪ್ಪ ಇರೋದು ಕಾಣ್ತೀರಿ, ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗಿದ್ದು ಕಾಣ್ತೀರಿ. Same time I told in the beginning also, when you keep the pencil or pen, it will be a little bit bent there. That is why, because when the light is moving from one medium to another medium, whether it is rarer medium to denser medium or denser medium to rarer medium, this is because of this thing. Okay, next one. ಜಸ್ಟ್ ಇದು ಸ್ವಲ್ಪ ಇದೊಂದು ಪವರ್ ಆಫ್ ಲೆನ್ಸ್ ಇದೆ, ಇದೊಂದು ಕೊಟ್ಟಿದೆ ಸರ್ ಅಷ್ಟು. ವಾಟ್ ಈಸ್ ದ ಪವರ್ ಆಫ್ ಲೆನ್ಸ್? ಐ ಟೋಲ್ಡ್ ಯು ಪವರ್ ಆಫ್ ಲೆನ್ಸ್ ವಿಲ್ ಬಿ ಸೇಯಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ, ಈ ಲೆನ್ಸಿಗೆ ಪವರ್ ಜಾಸ್ತಿ ಇದೆ, ಲೆನ್ಸಿಗೆ ಪವರ್ ಕಡಿಮೆ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇರ್ತೀವಿ ನಾವು. ಇವಾಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ನೀವು ಸ್ಮಾಲ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೇಕಂತಂದರೆ ಸೈಟ್ ಇರುತ್ತೆ, ಒಬ್ರಿಗೆ ಸೈಟ್ ಜಾಸ್ತಿ ಇದೆ, ಒಬ್ರಿಗೆ ಸೈಟ್ ಕಡಿಮೆ ಇದೆ ಅಂತ. ಆವಾಗ ನಾವು ಜಸ್ಟ್ ಜನರಲ್ ಆಗಿ ಭಾಳ ಜನ ಏನು ಯೂಸ್ ಮಾಡ್ತಿರ್ತಾರೆ ವರ್ಡ್ ಅಂದರೆ ವಾಟ್ ದೇ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್, ಅವ್ರ ಪವರ್ ಲೆನ್ಸ್ ಜಾಸ್ತಿ ಐತಪ್ಪ ಅದಕ್ಕೆ ಸೈಟ್ ಜಾಸ್ತಿ ಐತೆ, ಇವ್ರ ಪವರ್ ಲೆನ್ಸ್ಗೆ ಏನೈತೆ ಕಡಿಮೆ ಇದೆ, ಸ್ಪೆಕ್ಟ್ಸ್ಗೆ ಅದು ಕಡಿಮೆ ಇದೆ, ಗ್ಲಾಸ್ಗೆ ಸ್ಪೆಕ್ಟ್ಸ್ಗೆ. ಸೊ ವೆನ್ ಯು ಹ್ಯಾವ್ ದ ಸೈಟ್, ಸೊ ಆ ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಸೊ ಹೌ ದೇ ಡಿಕ್ಲೇರ್ ದ ಪವರ್ ಆಫ್ ದ ಲೆನ್ಸಸ್ ಹಿಯರ್? The power of a lens is the reciprocal of its focal length in meters. Reciprocal of focal length in meters in the sense, you can see here 1 meter is given there, P equals to ORF. Here he has missed 1, P equals to F equals to 1 will be there, then that is equals to P equals to 1 by F it is. Reciprocal of its focal length. Power is what? Reciprocal. Reciprocal means it is 1 by F it is, not F. If it is directly inversional, then we will go with F here, but it is reciprocal of F. So power length equals to, it will be always 1 by F. So the SI unit of power is dioptrate, we call it as. It is represented by the word D. Generally this will be used in lenses where he inspects if you have the sight or headache, whatever it is, to go with the correction of, we have myopia, hypermyopia means short sightedness, long sightedness, they will use this one. The power of the convex lens is positive and the power of the convex lens is negative. Underline one. This also I told in the last class. Convex lens power will be always positive and the power of concave lens is always negative. You might have seen. Okay, children, I told you the power of a convex lens is positive. See, it is very simple to understand also. If you won't remember, just remember convex. How will write convex? C-O-N-V-E-X. You remember the last letter. What it is? X it is. It is X. But this X can be written as in this form. If you write, it will become plus also. No doubt it is not exactly, but to make you understand, to make you remember, so you can write X as positive. So the power of convex lens will be always positive and the concave lens will be always negative. I told you concave, negative. You can find what you want here. Concave. So how to remember this concave? So we have V here. You know about this one. Convex we told you. Negative means we'll write negative. So this negative is for concave. When convex is positive, automatically concave will be negative only. It's simple, I told you. Just you click the X here, it becomes plus. Got it? Just you click the X, it becomes plus, then it is plus here only. So it is positive and power of concave is always negative. You might have heard while doctor prescribing the lens power, he will write plus 2.65 plus 0.25. Sometimes he will write minus 0.25, minus 0.15. They will write both at plus and negative. Why? Because of this is the problem there. Okay, between convex and concave. So which lens has to be used and why it has to be, whether it is left eye or right eye, whatever it is, this is what it is there. Okay, I think understood, children. So same classes we are done. Okay, children, I think this is the end of the chapter. So what I mean to say is, generally in science we have three parts. One is biology, chemistry and physics. This is the physics part which I am dealing now, and this is the last chapter in physics. So this is the end of the physics in those three groups in science. Okay, so if you have any doubts regarding any subject in physics, you can come to me at any time in class hours. When I was free in staff room, you can ask me. So it will be explained if you have any doubts. So go through well, read well. If you get the doubts, come to me. Once again, I will explain you what the doubt you have of any chapter of physics. And you may answer, still 2 chapters are remaining here. According to the rule, we have 2 chapters. One is the human eye and colorful world, and other is sustainable management of natural resources are given there. These 2 chapters are for physics only. But because of corona, what the government has did is, it has reduced the syllabus. So in reduced syllabus, these 2 chapters has been removed. So these 2 chapters are physics only. So these 2 chapters will not be considered for your annual exams because they have removed these 2 chapters. So that we have finished the physics chapter, physics portion of science. Okay. Thank you, children.